Well, 2.3 is a long section, but let's continue it. We don't have too many long sections. This just happens to be one of them. So we're going to continue looking at limits of different functions. So if you recall from your algebra class, this is something called a piecewise function. So a piecewise function, it means that if you have a value of x that is less than or equal to 4, we would use the first formula. And if the value of x is greater than 4, we would use the second formula. So the first problem says, what is the limit of f of x as x approaches 4? Now, from the left, it means from negative infinity or from values of x that are less than 4. So if x is less than or equal to 4, we use the first formula. So if we're looking for the limit as x approaches 4 from the left side, we're going to use this first formula. Okay, and so for that, we're going to use direct substitution, and it gives us negative 12 as the answer. Now, what happens if the limit of, what is the limit of f of x as x approaches 4 from the positive side? Positive, it means we're looking for the values of x that are greater than 4. So here. Okay, so positive means we're looking at as x approaches 4 from positive infinity, so from values of x that are greater than 4. So for that, we're going to use the second formula, and this, I'm sorry, this is not greater than or equal to, it should just be greater than. That's my fault. We're going to use the second formula, which is 2x minus 3. So if I plug in direct substitution, if I plug in x equals 4, I'm going to get 5 as the answer. So what this says is that as x approaches 4 from the left side, our limit is negative 12. As it approaches 4 from the right side, our limit is 5. And since our limits are different from the right and left, it means that the limit does not exist. Because remember, for a limit to exist, it has to be the same value from the left and from the right. Let's take a look at the next example. We want to find the following limit as x approaches 3. So first thing we're going to do is do direct substitution. And if you do direct substitution, we end up with 0 over 0, which I'm not going to go over, but we do get 0 over 0. So we have to factor this. Now, the word factor, it means to divide. Okay, the word factor, it means to divide. So if I want to factor the numerator, I can divide it by x minus 3. Because what we have here is we have a division problem. So I'm going to set up x cubed minus x squared minus 7x plus 3, and I'm going to divide that by x minus 3. Now, you may remember this from your pre-calculus class. If not, then what I want you guys to do is I want you to go to YouTube and I want you to look up synthetic division, or you can email me for a video and I'll be happy to send it to you. We don't use this much. We're going to mainly use it for this problem. But synthetic division, the way it works is we're going to set up the coefficients of the numerator. That's 1, -1, -7, and 3. And we're going to divide that by the root of x minus 3, which is 3. So remember, notice that it's a root of x minus 3. So if I set x minus 3 equal to 0, I get x equals to positive 3, and that's what I divide by. Okay, so inside we have 1, -1, -7, 3. Outside we have 3, which is the root of x minus 3. The way synthetic division works is you bring down the first number, and you always multiply the numbers on the outside. So 3 times 1 is 3, and you add the numbers on the inside. -1 plus 3 is 2. Then once again, I'm going to multiply 3 times 2 is 6. -7 plus 6 is -1. Once again, I multiply 3 times -1 is -3. 3 minus 3 is 0. So what I have is a 1, a -1, 2, and -1 as my new coefficients. But if I divide an x cubed by an x, then my highest degree now is going to be x squared. So this 1 will have the term x squared, and then we have a 2x, and we have a -1, and that's going to equal to 0. Okay? So if I divide x cubed minus x squared minus 7x plus 3 by x minus 3, it's going to give us x squared plus 2x minus 1. And now if I do direct substitution, I end up getting 14 as my answer. And you can verify all these graphically. If you graph x cubed minus x squared minus 7x plus 3 over x minus 3, and you look at the limit as x approaches 3, then it'll approach 14. Okay, so now we want to evaluate the limit as x approaches 0 of 6x plus 49 minus 7. First step, do direct substitution. If you do that, you do get 0 over 0. So that's the indeterminate form. Now remember, when you have a radical, so if you go back to this example here, when we had a radical, what we did was we multiplied by the conjugate, which is the radical x plus 2. So we're going to do the same exact thing for this problem, except it's a little more complicated because we have a bigger term. So we have radical 6x plus 49 minus 7. The conjugate of that is going to be radical 6x plus 49 plus 7. So the conjugate of radical 6x plus 49 minus 7 is radical 6x plus 49 plus 7. Now remember, the numerator, you can FOIL it, but the denominator, do not FOIL. Okay, the denominator, do not FOIL this. Only the numerator. Now on the numerator, if I FOIL this, what's going to happen is the following. I'm going to get radical 6x plus 49 times radical 6x plus 49. That just equals to 6x plus 49. Because if you multiply the same term inside the radical goes away. The middle term cancels because we get a plus 7 radical 6x 49 and then a negative 7 radical 6x 49. So those cancel each other out, so those are gone. And then negative 7 times 7 will give you a negative 49. That's going to be on the numerator. The 49 minus 49, that's going to equal to 0. So we're left with simply a 6x. Now we have an x on the numerator and x on the denominator, so I can cross those out. And I'm left with 6 over radical 6x plus 49 plus 7. At this point, I can do direct substitution, and this will give me 6 times 0 is 0, plus 49. Radical 49 is 7. 7 plus 7 is 14. 6 over 14, if I reduce that by 2, I get 3 over 7. Now, you might have questions on this, and that's exactly what class is for. So please come to class prepared with questions. Okay, last but not least, we have the limit of as x approaches 1 from the right side of x minus 1 over 1 minus x. Now let's think about this. So if x is approaching 1 from the positive, from positive infinity from the right side, then the values of x are going to be greater than 1. Okay, since we're looking at the values of x from the right side, x is greater than 1, an absolute value of x minus 1 will be positive. Like for example, if I have absolute value of 2 minus 1, it's x minus 1, and x is going to be bigger than 1, like 2, it'll give me a positive 1 inside the radical. If I have 3 minus 1, I'll have a positive 2 in the radical. So the absolute value, not the radical, I'm sorry, the absolute value will always be positive. So we're looking at a positive value of x minus 1. So I'm going to rewrite this, and if we were looking at it from the left of 1, we would have a negative x minus 1, because the value of x minus 1 would have been negative, but we're looking at it from the right, so x minus 1 will be positive. Okay, so we're going to have the limit as x approaches 1 from positive infinity, and because x minus 1 will always have a positive value coming from the right, I have x minus 1. Now remember that we can use a little trick. We have the same terms, but the sign, the x is positive on the numerator, negative on the denominator, negative on the numerator, positive on the denominator. So what we can do is we can factor out a negative 1 from the numerator. And if I do that, then remember, factor means to divide. So if I divide x by negative 1, it gives me a negative x. If I divide negative 1 by negative 1, it gives me a positive 1. Now negative x plus 1 and 1 minus x, it's the exact same thing in a different order. So my limit is just going to be negative 1. Now just to clarify, what if, just as a what if we had the limit as x approaches 1, but from negative infinity? Then x minus 1 would have a negative value. So it would be this case. It would be a negative parentheses x minus 1 over 1 minus x. Okay, so in that case, I would distribute the negative. So negative x would be negative x. Negative times a negative 1 would be a positive 1 over 1 minus x. Same thing. Negative x plus 1 or 1 minus x is the same thing, so that's going to equal to 1. So if we had a limit as x approaches 1 from negative infinity, then the limit would be equal to 1. Which means the limit as x approaches 1, it does not exist. Because from the right side, it's negative 1. From the left side, it's positive 1. Therefore, the limit does not exist. All right, please come to class prepared with questions, and I'd be happy to answer them. Here are 3 special limits to memorize. Limit as x approaches 0, sine of x over x equals to 1. Limit as x approaches 0 of 1 minus cos x over x is 0. And the limit as x approaches 0 of 1 plus x to the 1 over x is equal to e. These are just some things that you have to memorize for later use.